Okay, so you were telling me the other day about stars, what they're made of, and how far away they are. But I just found out something that makes all of that look like we're only reading the table of contents of a book. Apparently, all the matter we've talked about, stars, planets, even us, only makes up 5% of the universe.
Wait, 5%? What's the other 95%? Is the rest of the universe just empty?
That's the thing. It's not empty. It's filled with stuff we can't see. There's way more stuff out there, for example, dark matter.
Dark matter? That sounds like something out of science fiction.
It does, right? But it's real, very real. It actually makes up about 25% of the universe. However, because it doesn't emit or absorb light like ordinary matter, we can't see it directly with the typical optical telescopes. That's why it's called dark. We still don't know what it is, but we know it exists. It took a lot of meticulous work to just arrive at that conclusion and prove that it is a fundamental component of the cosmos. And we owe that to Vera Rubin.
Vera Rubin. Was she another one of those Harvard computers we talked about before?
Actually, she came a bit later, in the 1960s. But she faced similar gender barriers. For example, when she told her high school teacher she got into a great college, he literally told her, "You should do okay as long as you stay away from science."
Wow, imagine telling one of the most important astronomers in history to avoid science.
Well, lucky for us, she didn't listen. She ended up at the Kitt Peak Observatory in Arizona, studying how stars moved in Andromeda and many other galaxies.
So, don't leave me hanging. What did she find?
Something fascinating. Most galaxies are kind of flat, spinning disks, with lots of stars near the center and fewer at the edges. According to the physics known in Vera's time, stars at the edge should orbit slower than stars in the middle because there's less gravity in the outer regions. Kind of like how Pluto orbits the sun more slowly than Mercury.
That makes sense. Less gravity farther out, slower spin. But why did you say it was according to the physics in Rubin's time?
Because Vera's measurements told a very different story. The stars at the very edge were moving just as fast as the ones in the center.
Wait, if they're going that fast, shouldn't they just fly off? Like a merry-go-round spinning too fast for the kids to hold on.
That's the thing. Based on the matter we could see, they should have. But they didn't. They stayed in stable orbits. Vera realized something had to be providing extra gravity, a massive amount of invisible matter, forming a kind of halo around the galaxy. And that mysterious something was dark matter.
So she found that dark matter works as an invisible glue of the universe?
Exactly. The term dark matter was actually coined by Fritz Zwicky decades earlier. He had inferred that there was missing mass in galaxy clusters, but his calculations were rough. Vera Rubin came along and provided extremely precise measurements, studying dozens of galaxies. She gave us the first systematic, irrefutable evidence that this invisible matter really exists.
Did she get the Nobel Prize for that?
You'd think so, right? Her measurements opened a whole new window in cosmology. Today, we have multiple independent lines of evidence for dark matter, all building on what she discovered. But she never got the Nobel.
That's truly a pity.
It is. Still, she broke other barriers too. She became the first woman allowed to use the famous Palomar Observatory, and when she got there wasn't even a women's restroom. She literally taped a skirt-shaped piece of paper over the men's sign on one of the doors to claim her space.
I love that. She wasn't just finding new matter. She was making space for everyone else.
She really was. She was famous for making sure her students got credit for their work, and always said the real prize was discovering something new, not fame.
And 6 decades later, we still don't know what dark matter is.
Nope, but we might be closer than ever to figuring it out. New observatories like the CTAO are searching for exotic particles that could make up dark matter. Who knows? Maybe Vera Rubin will find the final answer soon.